In this class, we evaluate the value of integration 0 to pi by 2 sine to the power n theta d theta and integration 0 to pi by 2 cos to the power n theta d theta by beta and gamma function or beta and gamma integral. Okay, we know from the definition of beta integral, we can write beta function beta mn, this is equal to integration 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. And we know that this is an improper integration, and this improper integration is convergent only when m greater than 0 and n greater than 0. That is, m and n are real number which are greater than 0. Then this integration is convergent. And we also know from the property of beta function that this is equal to beta nm. That is, we know that beta function is symmetric about m and n. And we already discussed the relation between beta function and gamma function in previous class. As beta mn or beta nm, this is equal to gamma m into gamma n by gamma n plus n. Okay, we use this definition and this relation also. Now here we put first x, this is equal to sine square theta. Okay, now if x equal to sine square theta, then we get dx, this is equal to 2 into sine theta cos theta d theta, and the range of x and theta is also be changed. Here the range of x is 0 to 1, and so the range of theta is 0 to pi by 2. Right? Now the integration becomes integration 0 to pi by 2, and this is sine square theta whole to the power m minus 1 and 1 minus sine square theta, this is to the power n minus 1 into this is 2 sine theta cos theta d theta. And this relation gives 0 to pi by 2, this is sine to the power 2m minus 2 theta, this is cos to the power 2m minus 2 theta, and we write 2 outside of the integration, this is sine theta cos theta d theta. Okay, now this is 2 into integration 0 to pi by 2 into sine to the power 2m minus 1 theta, because this is 2m minus 2 plus 1, this is sine to the power 1 theta, and similarly this is cos to the power 2m minus 1 theta d theta. Okay, so we get this integration, that is the integration 0 to pi by 2 sine to the power 2m minus 1 theta into cos to the power 2m minus 1 theta, this is equal to half into beta mn. We get the result from the definition of beta function. Right? Now if we put 2m minus 1, this is equal to p, and 2m minus 1, this is equal to q, then we get m, this is equal to p plus 1 by 2, and n, this is equal to q plus 1 by 2. Now putting the value of m and n here, and also in this integration, we get the result as integration 0 to pi by 2 sine to the power p theta into cos to the power q theta. This is p, this is q d theta. This is given by half into and this is half into beta. In place of m we put p plus 1 by 2. So this is p plus 1 by 2 and this is q plus 1 by 2. Now comparing the definition of beta function, that is beta mn, we already says here this integration is convergent only when n greater than 0 and n greater than 0. So from this integration we must introduce a condition or introduce a constant here. We have to write p plus 1 by 2 must greater than 0 and q plus 1 by 2 must greater than 0. So p greater than minus 1 and q greater than minus 1. And under this condition, the above integration, that is this integration, is convergent. Okay. Now to find this type of integration and this type of integration, here we name this integration as 2 and this definition as 1. And in 2 we put p this is equal to n and q this is equal to 0. Okay, p this is equal to n and q this is equal to 0. Then left side integration is 0 to pi by 2 into sine to the power n theta into cos to the power 0 theta, because we put q this is equal to 0. So cos to the power 0 theta means 1, that is d theta, and the right side is half into beta, this is n plus 1 by 2 comma half, right? And also to find this type of integration we put p this is equal to 0 and q this is equal to n. Then we get integration 0 to pi by 2, this is sine to the power 0 theta. Okay, this is 1, and the second term is cos to the power n theta d theta, this is half into beta, this term is half and this term is n plus 1 by 2. And we also know from the first line, we know that beta mn this is equal to beta nm, and it is clear that these two functions are same, because this is n plus 1 by 2, this is half, and there is half and n plus 1 by 2 interchange. So we can write integration 0 to pi by 2 sine to the power n theta d theta, this is equal to integration 0 to pi by 2 cos to the power n theta d theta, this is equal to half into beta n plus 1 by 2 comma half. Okay, so we find the result of this type of integration, and this type of integration must be equal. And here we take n greater than minus 1, this is any number, any real number, and it must be greater than minus 1. Okay. Now in special case, if n is a positive integer, okay, n is a positive integer, and in this case there be two sections or two parts. At the first part we let n is even positive integer, and in the second part we discuss n is odd positive integer. Okay, now in the first case, that is in the case 1, if n equal to 2r, where r must be belongs to n, because this is any natural number, and 2r is even positive integer, right? And in this case the integration 0 to pi by 2 sine to the power n theta d theta, or this is equal to integration 0 to pi by 2 cos to the power n theta d theta. And in this case we write from this relation, this is half into beta 2r plus 1 by 2 comma half. Okay, so this is half into beta, this is given by r plus half comma half, right? And now we put the relation between beta function and gamma function, and by putting this relation we can write this term as gamma r plus half into gamma half by gamma r plus half plus half. Okay, so this is half into gamma r plus half into gamma half by gamma r plus 1. Here we use two properties. The first property is gamma n plus 1, this is equal to n gamma n, and the second property, actually this property and second property are same, this is gamma n plus 1, this is equal to n factorial if n plus 1 is purely an integer. Okay, so by using these two property here, we get the result as half into, we use the property gamma n plus 1, this is equal to n gamma n. So the first step is r minus half into gamma r minus half, because if we take this is equal to n plus 1, so n minus 1 is r minus half into gamma r minus half, and another half gamma half here, and we write this property as r factorial. Okay, because r plus 1 factorial and r is a positive integer, and so r plus 1 is also a positive integer, so r plus 1 is r factorial, right? And continuing this process, we get half into r minus half into r minus 3 by 2 to the same type of expansion. We get the last term is half gamma half, because why? Because r is a positive integer. So after deduction r times, we get here gamma half, and we get another gamma half, and this is 1 into 2 into 3 to this term is given by r. Okay, now we already discussed in the previous class gamma half, this is equal to root pi. We prove this result. So we get a 2 gamma half. So 2 gamma half means this is root pi whole square, this is equal to pi, and the result can be written as, if we sum or if we calculate this result, we get 2r minus 1 into 2r minus 3 to 1. Okay, and this is pi by 2. Here from these two result, this is pi, and we get here half, and the lower term is r factorial. This is 1 into 2 into r, this is r factorial, and also we can write this 1 into 2 into 3 to r, and we get another 2 to the power r. Now we multiply here 2 to the power r, 1 to each of this term, this r term, and get the result as this is equal to 2r minus 1, 2r minus 3 to the last term is 1, so the previous term of 5 into 3 into 1 by, we write this result reverse order. The first term is 2r, because this is r into 2, and then the second term is r minus 1 into 2, so 2 into r minus 1, or we can write this term as 2r minus 2, and the 1 is becomes 2, and the previous term is 4, then 6, and so on, and another term is pi by 2. Okay, and the result is can be written in the symmetrical form as 2r minus 1 by 2r, and 2r minus 3 by 2r minus 2, and this is half into pi by 2. Okay, so we get, if a equal to 2r, then the value of the integration is 0 to pi by 2 or 0 to pi by 2 cos to the power n theta or cos sin to the power n theta are same, and this is equal to this. Okay, and we easily use this type of integration and this formula, and we easily find the value of any 0 to pi by 2 sin to the power 4 theta, sin to the power 6 theta, and so on. when this is even. Okay, now we discuss the case when n is odd. That is when n, this is equal to 2r plus 1. When n this is equal to 2r plus 1, then we get n this is equal to 2r plus 1 and the case 2. And from this relation we get this is equal to half into beta. This is 2r plus 1 plus 1 by 2 comma half. And this is half into beta. This is given by r plus 1 comma half. And using this relation we get half into gamma r plus 1 into gamma half by gamma r plus 3 by 2. And we expand the gamma function by using this two property and get the result as half into this is r factorial, this is r factorial into gamma half, and the lower term is, the first term is r plus half, the second term is r minus half, and similarly we get the last term is half gamma half. Okay, using the property gamma n plus 1, this is equal to n gamma n. Here it is clear that gamma half and gamma half cancel out. So in this type of formula, that is n equal to 2r plus 1, in the formula there be no pi. And from this result we get, or we can write this result as, this is half into r minus 1 into r minus 2 to 2 1, and the lower portion is 2r plus 1 2r minus 1 to 3, previous term is 5 and 1, because these all are odd number and there be n number of 2, and we multiply 2 to the power r, this is r number of 2 on the upper side, and we get the upper term as half into 2r minus 2, and this is 4 and this is 2, and the lower term is 2r plus 1 2r minus 1 5 3. Okay, and we write this result systematically or symmetrically as 2r by 2r plus 1. Okay, and the second term is 2r minus 2 by 2r minus 1, and so on. This is 2 by 3, and this is the result of this integration or disintegration when n is odd 1. That is when the value of n this is equal to 2r plus 1. Okay, and these two are very important formula, and we using this formula we easily integrate this type of integration. Okay, now we use this formula and this formula, we see that how easily solve any integration of this type. If we take integration 0 to pi by 2 sine to the power 4 theta d theta, clear? And then obviously 4 is an even number, so we write this result as this result as we starting from 3 by 4 into 1 by 2 into pi by 2. Okay, because we starting from 2r minus 1. If 2r is 4, then starting from 3 by 4, then we decrease 2. So we get 3 minus 2, this is 1, and 4 minus 2, this is 2, and the last term is pi by 2 because of this, and we get pi by 2 when we arrive at half. Okay, and if we have to find the integration 0 to pi by 2 cos to the power 5 theta d theta, then 5 is an odd number, then we get the result as 4 by 5 into 2 by 3 into 1, because we use this formula. Okay, then we start from 2r, that is 2r plus 1, this is equal to 5, so 2r this is equal to 4, and 4 by 5, and again we decrease 2, So 4 minus 2 is 2, 5 minus 2 is 3, and if n fraction is 2 by 3, then we write here 1 because of this formula. Okay, and this is very, very important formula, and we deduct these two formula from using beta and gamma function. Okay, thank you for watching.